Hey, hi guys, this is Mr. Urrego, and today we're going to do transformation rules for functions. Some people call it transformation of functions, just that. Other people, books, call them graphing techniques transformations. What's the idea? I'm going to transform a function, okay? In that regards, I got to go to this list of functions. Don't get scared, all right? We have how many? 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so we have 9 parent functions. These are called parent functions. Why parent? Because this is your most basic function of that type. All right, parent function. This list, all those 9, are called a library of functions. Library of functions. And the idea is to understand how they look like, what's the domain, what is the range, what is the whole thing. I'm not going to go through this right now. I'm going to use them. I'll do a different video explaining the domain, the range, the intercepts, and the whole thing. Okay? Right now, what I'm planning to do with these library functions is to transform them. Okay? Transform them. What do I mean by that? Moving to the right, moving to the left, up, down, make them wider, make them narrower, make a reflection. For that, I'm going to use this table chart. I got this from mathlearning.com, something like that. Thank you for those people. Nice chart, nice chart. You know what? Let me get the right information. Where is it? There we go. Onlinemathlearning.com. All right, thank you to them. They did amazing chart. So these are transformations. These are the rules. This is what's going to happen. This is my basic function. F of x. Where's my thing? F of x. Let me show you. This is f of x. So this is my function. Square root of x. That's my basic function. Or cube root of x. So when they said f of x, this is what they mean. You know, any of them. Any of these functions. All right. So when I'm going up or down, my function will have a number adding or subtracting at the end, after the function. Okay? So I'll show that in a minute. If it's inside the function, then it will be a horizontal translation. Outside, adding or subtracting at the end. If it's adding, I'm going up. If it's subtracting, it's a vertical translation, I'm going down. If it's added on the inside of the function, it's a horizontal translation and is opposite to whatever the sign is. If it's positive, then it goes to the left. If it's negative, it goes to the right. Okay, and here I'm showing you what happens. Plus d, you're adding a d value to the y. You're subtracting a d to the y. So going up, going down. Here, you're subtracting to the x. Meaning I'm going to the left. Remember, x is your horizontal movement, y is your vertical movement. So if I'm going to the left, that means my x value will be a minus. I'm subtracting, therefore I'm moving my graph to the left. If I'm moving to the right, translation right, that means my x will be added a number. But when I have that in my original function, it will be a minus. So opposite sign. Opposite sign. When there's a negative on the outside of my function, that's a reflection over the x-axis. What happens? The y value will change the sign. Okay, that's a happen. The y will turn into a negative y. This is my original point. This is the one that is being transformed. The next one. Oh, what about the x is inside the function? That's the one that is negative. That means it's a reflection of the y-axis. And what's happening? The x coordinate will change the sign. All right, here comes the interesting ones. This is a vertical stretch or compression. That value is in front of the function, and that is multiplying on the outside. All right, multiplying on the outside. If that value is greater than 1, it's going to be a vertical stretch. And again, what am I affecting? I am affecting the y value and is being multiplied by that number. if that a value, anything between 0 and 1, meaning a fraction, 1/2, 1/3, 1/5, or by that regard, any negative as well, because this is an absolute value. So I can have a negative 1/3, negative 1/4. Absolute value will be between 0 and 1. Then I'll have a vertical compression. For the most part, the stretch is when the graph is narrow. Okay, many teachers say narrow. Compression, when your graph becomes wider, all right, than the standard one, than my parent function. Okay, what about if I have a value inside with my function, with my x? Then what that happen is, let's go back again. The absolute value of that number, if it's greater than 1, there's going to be a compression, but horizontally. And I'll change that. I'll show you on my Desmos in a minute. What happens with the x and the y? The x, the value will be dividing the x value. So horizontal compression or stretch, the x will be divided by that value. Right? Keep that in mind. All right, so let's do something. Here we go. So let's go to Desmos. Here we go. Desmos, online tool, free, no charge. I'm going to show you how every single graph looks like. My first graph was square root of x. This is what a square root of x looks like. Here we go. My graph starts at 0, 0, and it has an arrow to the right. That's the square root. Cube root. Here we go. My cube root goes to the left, goes to the right. I'm supposed to have an arrow there and an arrow there. So my graph goes to the left and goes to the right. Keeps going. What about the square? So this is the quadratic function. It's a parabola. All right. This is your minimum. This is your vertex. You will have an arrow going up, an arrow going, an arrow going up on both sides. Quadratic. Your cubic is very similar to the cube root, but the cube root was going horizontally, right? The cubic function is more vertical. I have an arrow going up, an arrow going down, and they go through the origin. Absolute value. The absolute value function, let me go back again just to make sure that you understand that. Absolute value function is this one, absolute value of x. All right. The thing is, on Desmos, I have to write abs. That means absolute value. And it's a V-shaped graph. I have an arrow to the right, arrow to the left. There's symmetry among the y-axis. The next one, y equals 3. Horizontal line. Arrow to the right, arrow to the left. That's a constant. I can have it 3. I can have it 5. Meaning it's going to go up, but it's horizontal. I can have a negative number, any constant number. So that's f of x equals b, your constant function. What's next? F of x equals x. F of x equals x. Identity function. All right. In Desmos, I don't have to write the first part. I don't have to write f of x. That's why I only have the x. But still, if I write f of x, there's no problem at all. F of x close equals. The thing is that sometimes it gets a little confused. You see that? It's changing, so I don't want to do that. So that's your f of x equals x. Your identity. I have an arrow going to the right, arrow going down. Arrows is a diagonal. Excellent. Next, reciprocal function. Reciprocal. F of x equals 1 over x. This is a rational function. All right? Rational function. I have arrow here, arrow to the top, arrow to the left, arrow to the bottom. Last but not least, I have my greatest integer function. It's also called the floor function. F of x equals int of x. Integer x. It's called greatest integer function. This is an example of a step function. Let me show you on Desmos. So Desmos actually, it doesn't show like greatest integer. It shows like floor function. You see that? There we go. That's my floor function. Steps, steps, steps. It's called a step function. All right. Again, I'm just giving you how each function looks like. I'm not explaining in detail any of the functions because by itself, every single one of them is a whole lesson. What was the idea of this? For you to recognize what's an absolute value function. What's the cubic function? How does it look like? All right, that's the whole idea. Because transformations are the quadratic. How does the quadratic look like? Because in transformation, what's going to happen is now I'm going to move this function up. I'm going to move it down to the right, to the left, and so on and so forth. So let me start doing transformations. All right, now this is just an introduction to a library of functions. Let's get into the lesson, which is transformations. So now let me apply these transformations on one. Let's go to Desmos. And now this is the square root function. Again, f of x equals square root of x, right? Just in case. F of x equals square root of x, square root function. The reason I use that one is because there's only a piece of a graph, right? I start here in the origin and it goes to the right. So I have a plus 3 on the outside, a minus 2 on the outside, but here I have it inside my square root. So when it's on the outside, when it's on something on the outside, that's vertical movement. It's going up, whatever number it is. X plus 3. So that means it's going to go up 3. Look at that. This point 0, 0 went 1, 2, 3 up. So every single point of my graph will go up 3. Look at this point. 1, 2, 3. So that's vertical movement. What about if I had a negative? Let's close that. I go back to my parent function. Negative. Oh, it went down. It's outside my radical, so that's vertical movement. Okay, it went down 2 every single point. 1 and 2. 1 and 2. You see the 2 boxes right there. Even better. Great. What about if I have that inside the radical? So that's what happens when I have here inside with the x. This is what it means. Inside with your x. So inside the radical with your x. So this is a 3 inside. What was the rule? The rule is opposite to that. If it's a positive, then it's going left. How many steps? Whatever the number is. So if I have a plus a number, it's going to the left. I have a plus 3. That means I'm going to go 3 to the left. 1, 2, 3. I'm grabbing this number by the origin. 1, 2, 3. Went to the left 3 times. If instead of a plus 3 on the inside, I give you a minus 2. What's going to happen with this minus 2? Again, inside, so I'm thinking opposite. Negative should be to the left, but no, because it's opposite, it's going to the right. So it's going to the right 2. Here, 1, 2 steps. So every point is going to be moved to the right 2 steps. Normally, with every single of these functions, what you do is you choose a point. And then you said, I'm going to move the whole function from there. It's like grabbing my function from here. And let me move it once and twice. So every single point moves twice. Next, outside my function. I have a negative outside my function. A negative outside the function. That means it's a reflection over the x-axis. So my x-axis will be a mirror. Okay, my x-axis will be a mirror, meaning this is going down. It's going to be reflected down. Let's see. Oh, this point reflected down. Every single point reflected down. All right, and the y is the value that is changing. For example, the x is 5 here and the x is 5 here. What changes is the y value. Here is supposed to be like 2 point something. The reflection now is negative 2 point something. So it changed. This is a reflection over the x-axis. What I have the negative inside the function with the x. Inside the function with the x is a reflection over the y-axis. The one that changes is the x value. Let's check. Inside the function, reflection over the y. So all this will be reflected in the other side. Okay, let's find out this is okay, let's find out. Oh, here we go. You see that? this point, let me see this point, got reflected. This is 4, 2. Look at this, -1, -2, -3, -4, 2. So the x value is the one that is changing. The y value stays the same. 4, 2 will give me -4, 2. Let me see that. 4, 2 will give me -4, 2. So it's the x value that is changing. Reflection over the y-axis. By the way, I'm giving you all this information in one graph. All of them behave the same way. Right now, the idea is to see what is the movement, what is the behavior, to identify where's my graph going. Okay, let me give you a different example with the quadratic, for example. Okay, so right now, the only thing that I'm missing is the vertical stretch, vertical compression, and this bottom. Let's do another function, any function. The idea that I did this one is because it's easy to see the reflection. Let me show you an example where you're not going to see the reflection. Something like, let me show you, let me see, the cubic function. I'll be back. Let's say that I have a cubic function. This is my cubic function, right? Up, arrow on the bottom, arrow on the top. Okay, let's say that I want to show you a reflection when there's a negative outside the function. Let me go to over here. When there's a negative outside the function, it's a reflection over the x-axis. So let's do that. What happened? So whatever was on the top now is reflected on the bottom. Whatever was on the bottom gets reflected on the top. But look what happened when I have the negative inside the function. So let me stop that one. This is my reflection. All right, let me turn this one. This is going to be reflection over the y-axis. What happened? They're the same thing, right? So let me give you the original. If it's going to be on the y-axis, now this is going to be reflected to the other side. And the bottom is going to be reflected on the right side. And my graphs look the same. So that's why I decided to do the square root function to show you all those transformations. One that is good to show here could be the quadratic, for example. The quadratic is an easy one. Then this is my quadratic function, parabola. If I have a negative quadratic, okay, that's a reflection over the x-axis. You see, the black one is the origin of my parent function. If I have a negative there, it's going to be a reflection over the x-axis. All right. What about if I have a number on the outside? Okay, so let's make it narrow. Let's make it wider. So let's say that I have, let's say I have 4, for example. So my original function is the x squared, the black one. All right, the red one is the one that has a 4 in front of it. So technically, this is when there's a number in front of the function, that's called a stretch. A in number in front of the function, if it's greater than 1, it's a stretch. What do I mean? The example that I put is, pretend that there's somebody on the top of this, and it's pulling, stretching your graph. So now, it used to be more wider, but when I pull it up, I'm closing and making this narrow. What about if I put a fraction on front of it? 1 divided by 2, right? X squared. Oh, it's the blue one. It's getting wider. It's getting much wider. Let me put a 5th so you can see that is, you see how big that turned on? The blue one is getting wider. So let me show you a table of values. I think that's going to be a good way to do it. So let's plug these values here. X is -2. -2 to the second power, +4. -1 to the second power, +1. 0 square, 0. 1. 1 square, 1 times 1, 1. 2. 2 square is 4. I create a table of values here. Why? Because I want that to graph. I want to graph that so I can show you, hopefully, a more clearly way that how it gets narrow or why. So this is my parent function, f of x equals x squared. -2, 4, -2, and then I'll go up 4. -1, -1, -1, and up. 0, 0. Let me change the color, by the way. Let's start with red. 0, 0, my origin. All right, so those are the points. So those are the points for my graph. The other side, 1, 1, 1, 1. So there's symmetry among the y-axis. 2, 4, 2, 1, 2, 3, 4. Right? So that's my curve. That's the parabola. Here we go. Oops. Here we go. That's my parabola. And I just changed. Now, let's do something here that let's pretend, let's put a 2. If it's a 2, my graph is going to be more narrow. Okay? It's going to be a stretch vertically. And when I say stretch vertically, pretend that I'm pulling my graph up. Stretch. I'm stretching. So, this is a stretch vertically. When I do a fraction, either positive or negative, this is a vertical compression. So instead of pulling, I'm pushing down. I'm compressing. All right, so that's what I meant. And I just want to make sure that that's clear. If I make a table of values, you will see that. Same thing from here. If I create the same table of values with the same values on this one, let me see, negative 2. Negative 2 to the second power is 4 times 2, 8. Negative 1. Negative 1 to the second power is positive 1 times 2 is 2. And this is symmetry. This is going to be 2, and this is going to be 8, right? Because it doesn't matter if it's positive or negative. As you can see, look at the y value. It was 4, now it's 8. So it's a stretch. It's going up. Before, this is 1. Now the y value is a 2. It's higher. So it's a stretch. I'll graph that in a minute. What about here? So this is my parent function. I always compare anything to my parent function, my most basic function. All right, if I have this, 1/2 of x squared. Remember, all this is using PEMDAS, all operations. Negative 2. Negative 2 to the second power is negative 2 times negative 2, which is positive 4. Half of 4 is 2. Negative 1. Negative 1 to the second power is negative 1 times negative 1, which is positive 1. Half of 1 is half. 0, and then symmetry, 1/2 and 2. So look, it used to be 4, now it's 2. So instead of getting bigger, it went lower. All right, so it's a compression, it's pushing those values down. Let's try to graph this really. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's going to be 8. Okay, here 1, 2, 1, 2. All right, I don't need that many. 1 and 2. Okay, so let's plot this. Negative 2 and 8. Negative 2, 8. This point used to be here. Now it's up here at 8. You see that? At 8. So it got pulled to the top. So it's a vertical stretch. The next one is negative 1, 2. Negative 1, 2. Let me get it red again. Negative 1, 2. And this is negative 2, 8. So this point used to be negative 1, 1. But it got moved higher. So it's a stretch. Okay? 0, 0, and same in the other side. So now look at this graph. It's much narrower, all right? So this got pushed because it got pulled to the top. It got closer. In the other side, negative 2, 2, negative 2, 2. This used to be 4. So it used to be 4 and now it's 2. So it got pushed down. Used to be this value, got pushed down. The next one is negative 1 and now 1/2. Negative 1, 1/2. It used to be negative 1, 1. So it got pushed down. So this is a compression. Look at that. Look at my graph. If I'm going to graph that, look how much it opened compared to my parent function. So when I have a big number, it's a straight vertical stretch. When I have a fraction, it's a compression. The horizontal, what happens is, horizontally, now let's think about horizontally. Let's not think about vertically. So this is a stretch vertically. But if I'm thinking horizontally, now I have to think, oh, hold on. Am I pulling my graph horizontally, or am I pushing my graph horizontally? Originally it was like this. Now the point is here, so it's being pushed. So what is a vertical stretch? It's a horizontal compression. Now let's look at horizontally. Originally it was here, now it's here. So technically I'm pulling this graph. I'm pulling to the right. I'm pulling this arm to the right. So this is a stretch horizontally, compression, compress vertically, but stretch horizontally. All right, so that's the idea. The visual thinking, how do you see it, is the opposite to the vertical. Okay, and that's a tiny confusing, but that's kind of the most difficult part. All right, so what we're gonna do now is play around with a couple of graphs. Let's move them around. So let's say that I have f of x equals, my parent function is this, but I'm gonna give you, all right, I'm gonna ask you, I have this f of x equals, let's say that I have x minus 4 squared minus 3, and the question is, what happened between my parent and this? Okay, that's a normal question. What happened? So do I need to identify the graph right now? No. This number on the outside, vertical movement, right? So this, because it's negative, the movement went down 3. It went down 3. What about this one? That's horizontally, and it's opposite to the sign. So this one, it went to the right 4. So if my original function, right, is that, okay, let's get one with black. So let's grab it by here, and I'm saying it went to the right 4. 1, 2, 3, and 4. And it went down 3. 1, 2, and 3. And now my point, this point is here. Now I graph my whole function is that. That's transformation. That's what happens. Identify what happens. Let's say that they want you to graph something like this. Let's say f of x, right? F of x, and let's say that I have a negative 4 on the outside, and I have an x minus 1 on the inside. Okay, they ask you to graph this. The first thing you have to do is identify my parent function. My parent function is the square root function. You need to identify that my square root function, it goes from the origin, right? If I need to create a table of values, you create a table of values. You give values. You know how it looks like, so you can give 1, 0, 1, 2. Actually, this will give you decimals. Because it's the square root, you want a perfect square in there. So you want 0, 1, you want a 4 here, you want a 9, for example. Because when you plug these values inside, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 4 is 9 is 3. I'm plugging those values inside my function. So you're creating a table of values, right? I plug in those values and I got 0 here, I got 1 here, square root of 4 is 2, square root of 9 is 3. So I have a table of values. So this is how it looks like. But if I need to graph, those are the precise numbers. Okay? I'm just saying, any of these functions, you can create a table of values. All right. But what about now? I know that if I have an x on the inside, if I have a number on the inside, that number, it will be horizontal movement. This is horizontal movement. It's minus 1, so it's 1 to the right. Oh, I have a negative on the outside, but a negative in front of the function, I know it's a reflection. Is that a reflection over the x or the y? Yeah, that's a reflection over the x-axis. Over the x-axis. Meaning, this is the x-axis reflection. So it's going to be this way. Alright? So you can visualize it. 4. A 4 on the outside is a stretch. So it's going to be something like stretch. I'm pulling my graph down, stretch, I'm stretching. All right, so this is an easy way how to identify what's going to happen with the function. So that means I went one to the right, so let's go back. Hold on. This is horizontal movement, one to the right. One to the right. Okay? Reflection, reflection, and stretch over 4. So my final, let me use that, let me use green or something, because I don't want you to get confused with all this. So again, one to the right, one to the right, reflection over the x. So instead of going up, it's going to go down. Stretch. So instead of having this nice curve, I'm going to stretch it. Let's analyze what happens here. Okay, 3 different questions. The idea is to see what happens with these functions compared to the parent function. This is the x squared. What happened here? This is vertical movement. So quadratic is a parabola. Vertical movement, it went down 1. So my graph, my new graph went down 1. So it's the same curve. I don't know if it's going to be something like this, I think. It went down 1. That's it. Here, let's grab the blue again. I have a fraction outside my square root. So my parent function is a square root function. I'm sorry, that should be an x. Square root function. It has a fraction on the outside. That means that's a compression vertically. So my graph, square root function, okay, compression vertically. Compression vertically. So I'm doing with black. That means I'm pushing my graph down. That means compress. All right? That's my new function. Compression vertically. Next one. I'm doing with blue, right? Yes, go blue. My function is that. My parent function is the cubic root function. All right. How does my graph looks like? Oh my god, hold on, I messed it up. So my cubic root function is something like comes over here and flips. There you go. Better. Okay. My transformation is a negative on the outside. So this is a reflection number. Is a reflection is on the outside. Reflection over the x-axis. So let's do the reflection with black. Reflection over the x-axis. So if this is the x-axis, this part is being reflected to the other side. So this curve is this. The other piece on the bottom, that means it's going to go to the top. Therefore that. So my black is a reflection over the x-axis. What's on the top goes to the bottom. What's on the bottom goes to the top. Okay? Let me give you a couple more examples. Now let's do a little bit more confusing. Again, all the previous ones that I did are the most common ones. Square root, cubic root, absolute value, quadratic, all those are the most common ones. Sometimes they will give you a function which is whatever, any line, anything. And they'll say, all right, this is f of x. Okay, this is g of x. Do this. The idea is to understand what's happening. I have a negative in front of the function. That means a reflection over the x-axis. All right? So this graph is being reflected over the x-axis. So this point is right here. This point, how far is this point from here? You see this? How far? Then I go to the other side, about the same thing. And now my graph looks like that. Reflection over the x-axis. That's the blue one. Let's go over here. What's on the top is coming down. So I'm going to go like, there we go. It got flipped. What's on the bottom goes to the top. So, and I have like some kind of 8 or something. All right. So you need to understand that you're flipping. What's on the top goes to the bottom. What's on the bottom goes to the top. And that's a negative in front of the function. But what about if I have a negative inside the function? Okay. So let's change that to green. And hold on, I need to erase. So let's erase because if not, it's going to be crazy. You know what? Let's not erase. I hope it's not too crazy, guys. All right, green, green, green. Here we go. I'm changing the color. So what's happening? Inside, therefore, is not over the x-axis. Now it's over the y-axis. Okay, it's inside the function, so it's a reflection over the y-axis. So whatever is on the left goes to the right. So let me see. This piece is right here. You see how far? How far is this point from the y-axis? This goes to the other side, around here. This point is on the right side. That means you're going to go to the left side. How far from the y-axis is this? About that. And then what I do is I connect those. You see that? It's a reflection. What was on the right goes to the left. What was on the left went to the right. I hope that's clear. Same thing here. Over the y-axis. Remember, my original is the red. So all this, it goes to the, but in this case, you see that is already happening. So this is kind of the same thing. It's a reflection of the y-axis. So that happens sometimes on some functions when they have symmetry. All right, they have symmetry. What's on the right side, it goes to the left. But again, I have this. The idea is to understand, oh, am I reflecting over the x or over the y? All right, what if I have something like this? I haven't done any absolute value. So we have absolute value, all right? We know that our parent function is absolute value of x. And we know that my graph is a V shape, okay? Not two. This is symmetry on both sides. This is not a perfect. But we know the table of values, okay? Everything becomes, start from the table of values. So I say -2, -1, 0, 1, and 2. If I plug a negative value inside here, my answer is positive because there's no negative absolute value, right? Any absolute value, again, I'm plugging in the -2. Let me get a different number, different color. So if I plug this value inside the absolute value, so I'm going to have -2, absolute value of that is +2. If I plug in -1, absolute value -1 is +1, right? 0, 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So I'm creating a table of values. So this graph came from a table of values. -1, 1. -2, 2. Here, 1, 1. 2, 2, kind of. But that's where the things come from, a table of values. So this is my original function. If I want to move that, if I want to translate that graph with all this, I know that this is vertical movement. So I'm going to graph this, and I'm going to go down 1, 2, and 3. So I went down 3. Okay. This is a horizontal shift. So this is down 3. This is inside the function. So it's opposite sign. So if this is positive, that means I'm going to the left. How many steps? 1. So I went down 3 and to the left 1. So I'm here. Okay. Now I graph my function. But now it has a 3 on the outside. Okay. So every value will be multiplied by 3. Okay. Because this is a vertical stretch. A vertical stretch. So instead of, remember, if this is my parent function, my vertical stretch will become something like this, right? I'm pulling my graph up, okay? If I need to create a table of values for this, I create a table of values the same way that I did for my parent function, all right? That's what I'm saying. Create a table of values. Plug it in there and use the order operations, okay? If I have, I don't know, -2, let's say that if I'm using the same values, -2, let's use -2 right there. I have 3, absolute value -2 plus 1 minus 3. What do I do? -2 plus 1 is -1. Then I do the absolute value. Absolute value -1 is +1. And then 3 times 1 is 3 minus 3 is 0. So what I'm trying to say is create a table of values if you need to. If they only ask you how does it look like, then you know that if you have a number that is greater than 1, that's going to be a vertical stretch. If it's a fraction, it's going to be a a vertical compression, meaning it's going to become wider. I'm pushing my graph down. All right, that's the whole idea, and that applies for any function. It doesn't matter if it's absolute value, if it's a square root, if it's a cube root, okay, any of them, they work the same way. All right. Again, this video can become very long, but the idea is to understand what happens with every single one of them. The idea is to understand these transformations. Where's it going? Up, down, left, right. Okay. Again, I hope this helps and to unconfuse a lot of people that are really confused with these functions. Please subscribe to the channel, like the video. There's the subscription button right in the middle. Please hit it, subscribe. It doesn't cost you anything, but it helps me a lot, okay? Because I need to start streaming, all right? Math help, that's the idea. Help more people. All right, guys, thank you for watching. I'll see you in the next one. Take care.